So I'm gonna go a little bit backward today. So we're gonna go back to yesterday's notes, and what did we figure out yesterday? So remember yesterday we did the parent function y equals x squared. You guys recall that? Yeah. And we learned equals x squared is my parent function. The graph of it would look like this. It's open up. The vertex is 0, 0. The x-intercept is 0, 0. Axis of symmetry is 0. And the optimal value is 0. And we learned that the step pattern is 1, 3, 5. So you go from the vertex up 1 over 1, up 3 over 1, then up 5 over 1. Just keep the parent function in mind when we're doing the other functions. Okay? So remember that the parent function is y equals x squared. Let's move to today's lesson. So we're going to investigate what happens if I multiply that x squared with a number. Okay? We call that number the letter a. Okay? So a times x squared. So that number could be any number between infinity to negative infinity. Okay? So it could be any number that you can think of. Positive, negative, fraction, decimal, whole number, whatever you pick. Or they pick for you. So the first function that you see right here, y equals x squared, that's your parent function, correct? The value of a is 1 because there's nothing in front of that x squared, so that is considered to be 1. The direction of opening, if you remember from yesterday, which way did it open? Up. What was your vertex? 0, 0. How about the axis of symmetry? X equals 0, right? Okay. Now what we're going to do, we're going to go to decimals, and then we're going to graph y equals 2x squared. So we have 2 for a. Okay? And then we're going to see what happens. We're going to compare the original one, the parent function, to that one. So on your decimals, you can start with writing y equals x squared. You see that button right here, the a squared button? You can press it and that will give you y equals x squared. Sorry? The a squared, you see that a squared?
Yeah.
If you press that, it will give you the square. So this is my parent function. So the red function in this case is the parent function. Are you guys okay with that? You have to write equal. There is an equal right here, Brian. Oh. Yeah. Okay. Now, if I want to graph y equals 2x squared, I'm gonna go to the tab right below it, and I'm gonna write y equals 2x and press the square button. So, looking at both graphs, what can you guys tell me? Compare them to me.
Same vertex.
Same vertex, which is 0, 0. What else?
Opened up.
Both open up. Good.
Same axis of symmetry.
Same axis of symmetry. Yeah.
Is 0?
X equals 0. That's right.
Both equal 4.
Huh? Both.
Y equals 4.
So they have the same form. That's what you're saying? 4. They're both parabola. Yep. How about?
I'm still trying to connect.
I figured it out.
Okay.
Where's the thing?
Now, which one is like? How can you describe the blue one with respect to the red one? it's not as wide, it's narrower, right? The blue one is narrower than the parent function. Okay? All right. Now let's graph the third function. What is it? Y equals what? 0.5x squared. Okay. Just if your phone's not working right now, just keep it on the side, please, and then just look at the screen on the screen, and then we'll focus on that. Okay, I graphed y equals 0.5x squared. What can you tell me about it? It's wider than. We're always comparing to the red one. Okay, so it's wider than the red one. What else can you tell me about it? Same vertex, 0, 0. Same axis of symmetry, and opens up. Okay, so what did that A value do to your graph? What did it change? It either made it more narrower or it made it wider. That's correct. Okay, so we've noticed that the only change is that the blue one, which had an A value of 2, made the graph narrower, and the green one, which had a value of 0.5 as an A, it made it wider. Mathematical term, we call that vertical stretch and vertical compression. Does anyone have an elastic band? No? Okay. Let me see if I have one.
I have one.
Okay, excellent. The same one I used last semester?
I don't think so.
All right. Okay, eyes on me for a second. So pretend that there is no top here, right? And this is your original x squared, right? I want to make this narrower. So what do I have to do to it to make it narrower? Pull it which way? Pull it up, right? And then it becomes narrower, right?
Yes.
We call that vertical stretch because I'm stretching it vertically. Okay? So instead of using the word narrower, right, for the blue one, I have to use the word vertical stretch. Is that clear?
Yes.
Now, same original x squared, I want to make it wider. What do I have to do to it? Push it down, right? You see how it becomes wider? We call that vertical compression because you are compressing it, you're pressing on. Okay? So, if I want to describe the blue graph, I'm going to say it was vertically stretched. If I want to describe the green graph, I'm going to say it was vertically compressed. Okay? So now let's see why is the blue graph is vertically stretched? What caused it to be stretched? It's that A value right here. Okay? Because that A value is greater than 1, it caused a vertical stretch. Okay? If the A value is between 0 and 1, then we have a vertical compression. These words are your math vocabulary. Okay? You must use them in order to get the correct answer. All right? So if I look at this, because this is a 2, right? Which is 2 is greater than 1, then I have a vertical stretch. Okay? I will write them again on the note. That A value right here is between 0 and 1. Okay? This is how we write it. It's between 0 and 1. Okay? then we call that a vertical compression. Okay? Yes.
It went to the opposite side, the formula.
What formula?
The way how you wrote it down, the vertical compress, one is going to the right and the other one's going to the left.
I'm not sure what you're trying to say here.
Right after up there.
Zero.
After zero, I mean.
This one? 0 is less than A, less than 1.
That means less.
That means 0 is between, the A value is between 0 and 1.
Oh, okay.
Yeah, that means less.
Alright.
Okay? In this case, A or 2, in general, if you want to write as A, is greater than 1. Okay? This means less. Okay?
Yes, thank you.
Here. Are we okay with this? All right. So let's go here, and let's fill out this. So for the 2x squared, what's the value of A? 2. Which direction was your graph open? Up. What's the vertex? Nothing changed, remember that? Remember, it did not change, it stayed where it was. The axis of symmetry. Now, if you want to compare this, we always have to compare it to the parent function, okay? If you want to compare this one to the parent function, what can you tell me? What happened? It was vertically stretched, okay? So, vertical stretch. I'm going to put in brackets narrower, but you don't write that on your test. I just want to keep it there so you guys remember how it looks like. Okay? Now with a 0.5, what was your 0.5x squared? What's the A value?
0.5.
Direction of opening? Vertex?
0.0. Vertically stretched.
X. Vertical what?
Stretch.
Vertical what?
Compress.
Oh shoot.
Compression. That's what?
That's here.
Okay.
Oh yeah, 0. Yeah, you're right.
Now, if you want to look at the other two, what can you tell me? Like the D is negative 2x squared, the E is negative 0.5x squared. So what's the difference between what we've seen already?
Negative.
And they're negative. Okay? The A value is negative. Okay? Let's try to graph that on decimals and let's see what happens. Alright?
Why it was not negative, like, yeah, negative 2x squared.
Yep. Just trying to move this.
So it goes down.
So y equals negative 2x squared. Down.
0, 0.
Okay? Vertex still the same. The difference is that now it's opening down. Okay? If you compare the blue one and the red one, they're exactly the same. Okay? The blue and the red, except one is opening up and one is opening down. Okay?
Different thing for vertical.
What is it?
Would you put a different thing for vertical, like vertically stretch, or?
It is still going to be vertically stretched because it's a 2, but we're going to also add to it, it's reflected, right? You see there is a reflection. Reflection means it's flipping, okay?
So axis of symmetry.
It's still the same. Axis symmetry is still x equals 0. It's not changing because your vertex is 0, 0. Okay? The only thing that's changing is that it's reflected. Okay? I'm gonna graph y equals negative x squared just so you see, you can compare the negative x squared to the. So you see, this is your red one reflected. Okay, so this is your parent function but reflected. Okay, if you compare the orange to the purple, the orange is vertical stretch, right? And it's reflected. It's
How did you do that? You just left on, or did you just?
for which one? For the purple one?
Oh, you put in a negative.
I just put a negative x squared. Okay. Now, what do you think y equals negative 0.5 x squared is gonna look like?
Another reflection.
It's gonna be reflection. It's gonna be the same as the green, which is a vertical compression, but it's reflected. Okay.
Reflected vertical compression.
We have to say it in two different sentences. I will show you what we are gonna have to write. Just give me a second.
That's it.
Okay, so let's write that down. So, what's the value of A? Negative 2. The direction of opening? Down. Your vertex? Axis of symmetry? 0. And we said it's a vertical stretch. But we're also going to add to it reflection. Okay, that's the correct vocabulary. Okay, so it has a reflection. Sorry, I did not know that you were reading.
I was just, I wanted to have this for today. Thank you so much for the interruption.
Okay, how about the next one? The value of A?
0.5?
Negative
0.5.
Are we supposed to write down reflection as the term since it's not in brackets like the others?
Sorry?
We could write down reflection as the term since it's not in brackets like the other two?
Yeah, this is, you have to write it.
Okay, great. Thank you.
You have to write it on the test, right?
Down.
It's down.
It's down, yeah.
That's 0. A compressed reflection.
That's right. So vertical compression.
Do you still put reflection for that one too?
That's right. Anytime you see a negative for the A value, what's the difference between a vertical compression and a vertical stretch?
Yeah. Is it more in? The compression is more in?
No, the vertical stretch, remember the elastic band? If
Yeah.
you stretch it vertically, it looks narrow.
Yes.
And that's why I wrote narrow here,
Okay.
right? You don't write the narrow on the test.
One is narrow, one is open.
That's right. One is wide. You're always gonna be comparing whatever function it is to y equals x squared.
Because that's the origin, right?
That's right, because that's your parent function. Okay, so any quadratic graph that you have or that you will have must be compared to the y equals x squared. We're always comparing to that. Okay. So, the sign of A. What does the sign of A tell you? Sign means it's positive or negative. What does the sign of A tell you?
Whether it's up or down?
Whether it opens up or down, right? The sign which is positive, up. Negative,
Down.
down. Remember I showed you that before when I wrote negative and I said to you, right, the A value is negative. Negative means open down because N starts with the letter with an open down. Okay? So the sign of A indicates direction.
The parabola opens up. If it opens up, does it have a min or a max? Min, right? Remember? When A is negative, the parabola opens down. Reflection. So that's the sign of A, if it's positive or negative. Now, the value of A, which means is it 1, is it greater than 1, is it between 0 and 1, it describes what? It describes the shape, which is the stretch or compression. So we're going to say describe the shape of the parabola. When A is between 0 and 1, so it's a decimal that starts with a 0, so 0.1, 0.2, 0.567, right? Any value that is between 0 and 1, the parabola is narrower or wider? Wider. Then y equals x squared, known as a vertical compression. Okay? V represents vertical. When A is greater than 1, the parabola is narrower, known as vertical strip. So you have noticed that the value of A only affects if it's going to open up or down, or if it's going to be wider or narrower. Nothing else. Everything else stays the same. The vertex stays the same. The axis of symmetry stays the same. The optimal value stays the same. Okay?
It's just that one side is positive, the other is negative.
It's just if it opens up or opens down.
Okay.
Okay? And if it's narrower or okay. Are we okay with this? By the way, that A value is the same in all three forms. We're going to talk about the different three forms. But that A value is going to be the same in all three forms. And it's going to do the same thing. So when you see that A value, you know right away. Okay. So these are some examples to basically that helps us with yesterday's lesson, not with today's lesson, because remember that whole lesson was supposed to be one lesson, right? So this is the graph, and they're asking you to find the zeros, the y-intercept, the vertex, axis of symmetry, and optimal value. So what are your zeros for the first one?
-1 and 5.
So -1
Positive here.
and +5. So you can write it in different ways. Remember? You can write it as and 5, right? So we're looking at these. Or you can write it -1, 0, and 5. Okay? Both forms are accepted as long as you write it exactly the same way I am writing.
Okay, is this on the line, the graph underneath?
Yes. I had to kind of zoom in a little bit because, so you guys can see. How about the y-intercept?
-2.
Y-intercept is -2, so I have to write y-intercept equals -2. Right, it's right here, so this is your y-intercept, right? And, or I can write it as what? Think that you're gonna make that mistake, write it like the first way. Okay? There's barely any mistakes you can make here. Okay? But here, if you switch them, I'm gonna have to count it as wrong because it's at all point. Okay? Vertex. What's my vertex?
2 and -4.
That's right. So the vertex is right here. It's your turning point.
Wait. What was the y-intercept -2? Oh, yeah, never mind. I was blind.
You got me lost here. Okay, the vertex is a point. There's only one way I can write that, right? The x value goes first, right, which is 2, and the y value.
That matters when writing more points, correct? X first and Y second.
That's right.
Okay.
The axis of symmetry, where's your axis of symmetry?
2.
X equals 2, remember? Format, guys, format. X equals 2. Optimal value?
4, -4.
Y equals -4.
Yeah.
Okay? Remember that this is always your axis of symmetry, and this is always your optimal value. So the vertex gives you the axis of symmetry and the optimal value. Okay?
So one answer could figure out both.
That's right. Okay, so I'm gonna give you like a minute to do this question.